Dan Sanchez, and welcome to the NPP Podcast, the biological technology show where size matters. We believe the secrets to solving some of the biggest development challenges in the world can be found in some of the smallest naturally occurring technologies. In the age of COVID-19, the importance and the incredible power of vaccines needs no exaggeration. It is one of humanity's greatest achievements to fight and beat viruses and diseases. But did you know that the same thing is happening in plants? That we are able to learn from viruses to make plants stronger and more resilient. This week, we're learning about a microbe that is a vaccine and how this type of technology is reshaping the natural world. Joining me today are Lara Raemaekers and Estelle Moreau. Lara is a global Biocontrol Portfolio Lead at NPP based in Belgium, and Estelle is technical leader for Biocontrol at NPP based in Saint-Malo, France. Welcome, both of you. Today, we're looking at the micropower Vacciplant, a preventative treatment that uses active biological compounds to stimulate the natural defense mechanisms in food and non-food crops. So, I'd love to hear, Estelle, what's the history of Vacciplant?
Yeah, actually, Vacciplant has quite a long story. It was initially developed by a French company named Goemon that was formed in 1971, that is now part of UPL. And when Goemon was created 50 years ago, it was based on the key idea that the plants were able to defend themselves against different kinds of pathogens. So the company for the biocontrol part has worked with a long-term collaboration with a research center. And thanks to this long-term collaboration, Goemon was able to develop the first vaccine that was ever registered in Europe.
And it was quite remarkable as well on this story with Vacciplant. It was actually one of the pioneers in biocontrol, one of the first products ever introduced in Europe, in the world, that was a biological, a purified seaweed extract. And even despite being a pioneer, it was even introduced on row crops. That's even a market where even today it's still challenging for biocontrol products. So in that sense, also this Vacciplant, it was really quite a pioneer already 20 years ago.
We have continued to develop this product, and we continue every day to identify new crop, new diseases, new way of application. So it's really a product which for which we always continue to learn, and that's why Lara and myself, we like this product so much.
That's right.
That's great. That's great. So tell me a little bit more. How does Vacciplant work?
We have identified an active to be used as a biofungicide. The name of this active is laminarin. So laminarin is a sugar that we extract from a natural compound, a seaweed that is present in the Northern Atlantic Ocean. And this laminarin will be then formulated into the product that we call Vacciplant. So the mode of action is quite complex, and the detail can be found in different scientific publications. But to simplify, so Vacciplant is a biofungicide that will act like a vaccine. Indeed, plants, like humans, have a immune system that will enable them to fight against diseases. These processes are quite common in the plant kingdom, which make Vacciplant a very interesting product for plant protection in agriculture. And one important point is that as Vacciplant will protect the plant through a kind of vaccine effect, it's like for human, you need to apply Vacciplant preventatively, which means you need to apply before the disease appear in the plant. And so the plants react a bit faster than human. We consider that plants need 2 to 3 days to be fully activated. And then as a result, when the disease really will happen, will occur, the plant will be ready and the disease will not be able to develop in the plant.
And on top of that, Estelle, what I find very interesting with Vacciplant is that lately, and only in the last 2 to 3 years, when we are, as you said, we are discovering more and more, we also see next to the biofungicide effect of Vacciplant, which is the main effect, we also start seeing some secondary effects of the product as a biostimulant. This was first reported in Florida on tomatoes, where even in absence of disease, growers could see a better yield and a bigger, healthier plants. And also in Brazil, last year, the Brazilian team discovered that actually Vacciplant was able to prolong the storage of lettuce, for example. So when it was sprayed close to harvest, the lettuce was kept fresh longer. And those are all huge benefits for a farmer.
But in reality, Vacciplant, what Vacciplant do, it will be recognized by the plant as if there was an attack occurring. And so the plant will activate a lot of different things. We call that different biochemical pathway, which will lead to modification of the genes. So it's really a deep down effect. A lot of different actions have to occur. And we know that the genes that will be activated by laminarin will be linked to crop protection, but also some of them will be linked to more biostimulant effect. But as a lot of other biofungicide products, we don't have only one mode of action. We have also secondary mode of actions, and as Lara said, some effect on biostimulant activity.
And that's a nice example, because this is often the case for biosolutions. We tend to know from conventional chemistry, we tend to classify a product as either a fungicide or an insecticide or a herbicide. But in biologics, it's so different. We see it's more a rule than an exception. Many AIs, many biological AIs have different roles. So we have so many examples, and Vacciplant is a good one.
And so, as a farmer looks at Vacciplant as a toolkit for them for growing their crops successfully, how do you place this particular technology with them? How do you position this as one of the important tools that they should be using?
Yes, so first of all, it's important to say that Vacciplant should always, as many products, as all products, have to be placed in a wise way in a program. And there in a program, Vacciplant can really show its added value, because by using Vacciplant and either replacing some of the conventional product sprays or by adding it to conventional product sprays, we can decrease the overall residue concentration, but also the overall number of residues of the program. And that's in the end very important and becoming more and more important for the farmer, for the consumer, for the whole food chain, right? So also for improving sustainability in this way. Apart from that, there are many other benefits, right? So the pre-harvest interval is 0 days, so it's very flexible. There is no re-entry interval. It means you can, for example, in greenhouses, you can spray the product and just, you don't have to exit your greenhouse for not even a minute. That's very important, for example, for the rose business in Kenya, or for vegetables or strawberries, for example, that are picked continuously. Another benefit, for example, is that Vacciplant is very compatible with other products, so mixing it is never a problem. It also has no secondary effects on microbials that are often used also as a biocontrol product and as an essential part of the program. That's also very important. So it has so many benefits. On top of it, if you tank mix it with a conventional, you can also increase the efficacy. So it's often positioned in timings where disease pressure is lower, and then it can be applied on its own in order to decrease then the overall residual levels and the number of residues of the program. But in high disease pressure periods, when it's added to the conventional, you can really increase your efficacy. A good example is powdery mildew on strawberry in the Netherlands, where thanks to this strategy, farmers are able to increase their efficacy levels by 30 to 40%. And those, we are speaking very high powdery mildew disease pressures in greenhouses and tunnels, etc.
And so, now Vacciplant is in the market and you're developing uses. Lara, I was wondering if you could expand on some of the success stories or some of the great uses that you've seen of Vacciplant for farmers.
I think a first good example to mention is the use of Vacciplant in a program together with sulfur on grapes, mostly for control of powdery mildew in South Europe. Even we are now extending to other diseases, but that's where the first initial success story was, where in a program with sulfur and Vacciplant, there was, and this is mostly on table grapes, farmers were actually able to use a fully organic program. Another very good example on a very different crop is the use of Vacciplant in the country there called Iodus on cereals in the UK. So if you apply Vacciplant early on wheat, for control of septoria and often together with contact products, you can really achieve also a better efficacy level in cereals for control of septoria. Next to that, we have many examples. The one I mentioned already on strawberry is a good one from the Netherlands. We also see increasing successes in, for example, in the US on tomato in Florida, where I also mentioned that even in absence of disease, farmers see an added value because of an increased yield on their tomato fields. Also, we see other good examples on bacterial diseases on perennial crops. We see a very good fit of Vacciplant together with copper or in different sprays, where Vacciplant is actually as efficient as copper, and that's quite remarkable, right? So this is, for example, on citrus. This is also a success story we are seeing, right? So Vacciplant, copper, and then even adding microbials, so bacillus-based products that we are also developing. And together, that one program can actually have quite a good control of bacterial diseases on perennial crops.
Indeed, that's one of the strengths of Vacciplant. Thanks to this mode of action, which is acting, we are using the plant, the defense function of the plant against the pathogen. So it means that potentially we have quite a broad spectrum with this product.
What Estelle is saying is important because of this indirect effect and no direct effect on a fungus, there is really no risk of any resistance development to Vacciplant, to the AI itself. And that's also, of course, very important.
Yeah, I was wondering, we learn more about Vacciplant, what your experience has been talking to farmers who have used it and perhaps participated in uncovering some of the benefits that we're seeing now from Vacciplant in the field.
Yes, so the biostimulant effect was really discovered by farmers. The first report we got was from, as I said, from tomato in Florida. Recently, we've also had some very nice stories from on grapes from California, where we also saw stimulating effects on the bunches of table grapes.
Yeah, it made me think that we forgot to mention a very important point. Vacciplant is indeed registered to be used in organic farming in EU. But I think that's a very important point also, showing how this product has a very good profile for the environment and how much it can bring to the farmer.
So we have indeed an EcoCert label, and we are working also on getting an OMRI label, which is another organic certification that's more, I would say, globally recognized, which we will get with the new formulation we are developing.
It's great to hear. Well, thank you to Lara and Estelle for a wonderful introduction to Vacciplant, the small technology that's making a big difference for crop resilience and plant health, as well as increasing yields. So again, this is just one example of where the planet is helping the planet. But you can learn more about NPP's work with micropower and macro impact at www.npp.ag. Thank you.